You lie back, your breath slow and steady, as the ordinary world begins to fade into softness. And in its place, another world quietly opens. A world not visible to your eyes, but present in every atom, every grain of dust, every flicker of light. A world so delicate and yet so fundamental that all of reality rises from it, the quantum world. You are invited now not to rush through it, but to float, to drift, to allow its mysteries to reveal themselves like ripples spreading on a still pond. And as you drift, you feel the comfort of knowing you do not need to solve its riddles. You need only listen to hear the whisper of quantum physics, the gentle murmur of particles moving in ways that defy common sense, reminding you that beneath the solidity of everyday life lies a dance far stranger, far subtler, and far more beautiful than you might have imagined. You imagine yourself shrinking smaller and smaller, beyond the scale of cells, beyond the spiral of DNA, down past the boundaries of molecules, until you hover in a space where electrons swirl like tiny fireflies around nuclei that themselves are made of. Quarks bound together by invisible threads. And as you drift here, you notice something astonishing. That these particles are not little marbles bouncing predictably, but clouds of possibility, shimmering, fading in and out of states, sometimes here, sometimes there, as if the universe itself cannot quite decide until the moment you look. You breathe into this thought, letting it soothe rather than unsettle you, for uncertainty at this scale is not chaos. It is order of another kind, a deeper order. A whisper that says reality is woven from probabilities, from potentials waiting to be realized. And you, simply by observing, are part of how the story unfolds. Imagine holding a coin between your fingers, flicking it into the air, watching it spin, heads and tails flashing. But in the quantum world, the coin is not merely spinning. It is both heads and tails at once, suspended in superposition, a word that means many states together, and only when you catch it in your hand does it choose, collapsing into a single outcome. This is not metaphor. It is how electrons, photons, entire atoms behave, existing in multiple possibilities until touched by observation, and you begin to feel the wonder of this, the softness of a reality that is not rigid but fluid, like mist shifting in moonlight, allowing countless paths until one is gently chosen. As you drift further, you sense another mystery, entanglement, where two particles become linked in such a way that distance cannot break their bond. And though they may be separated by galaxies, a change in one is mirrored instantly in the other, as if the universe whispers across space with no delay. Einstein once called it spooky action at a distance, and perhaps it is spooky in its defiance of classical thought. But lying here in calmness, it feels instead like intimacy, like the universe reminding you that connection is not limited by distance, that beneath the visible separations lies unity. You think of two lanterns glowing on opposite shores, their flickers moving in unison, or to dancers separated by oceans, yet still moving in harmony to the same rhythm. And you understand in your body that quantum physics is not only science, it is poetry hidden in the fabric of being. Let this soothe you. The ordinary world of chairs and trees and rivers is solid only because countless quantum whispers agree to align. Countless uncertainties collapse into shared outcomes. And yet beneath it all, the uncertainty remains. The dance continues, invisible yet constant, like a lullaby playing under the noise of the day. And as you rest, you sense that the rules of this quantum world are not just curiosities, not just puzzles for physicists, but the foundation of something profound that humanity is only beginning to harness, a new kind of computing. One that does not rely on simple bits of 1 and 0, but on qubits, on the shimmering superpositions and entanglements of particles, on the strange whispers of possibility themselves. But tonight, you are not asked to solve the mathematics. You are invited only to listen, to drift with the feeling that beneath every breath, every thought, every star in the sky, lies a hidden order of possibility, fragile and strong, familiar and alien, ordinary and miraculous, a world that whispers always, whether you listen or not. So let your breath fall into rhythm with this whisper. Let your body soften into the comfort of knowing that reality itself is more fluid, more mysterious, and more generous than it seems. And as you sink toward sleep, you carry the gentle thought that the quantum world is not distant from you. It is within you, around you, the unseen foundation of your being. And as you linger in this awareness, another question begins to arise softly, without urgency. If reality at its smallest scales is so strange, how did humans come to understand information at all? How did we move from counting stones to building machines? And how will those ancient beginnings connect to this quantum whisper? That story, the story of information itself, is where your journey drifts next. You lie still, your breath slow and steady. And as the whisper of the quantum world fades into the background like a lullaby lingering in the night, you begin to sense another story unfolding, a story not of particles but of patterns, not of probabilities but of the very idea of information itself. For long before humanity dreamed of qubits and entanglement, long before we glimpsed the fragile mysteries of the quantum world, we first had to discover something far more humble, far more ancient, the simple act of counting. And in this act, a new world quietly began. For information is not only the language of computers, it is the language of thought, of memory, of survival itself. And it has been with you since the earliest humans traced notches into bones to mark the passage of days, since hunters stacked stones to tally their kills, since mothers tied knots in strings to remember debts or promises. And as you breathe, you can imagine this scene: a campfire flickering under ancient stars, a figure pressing marks into a piece of wood, each line a whisper of information, a way to carry thought beyond the fragile boundaries of memory. And this simple act was the beginning of computation. You drift further back in time, imagining the very first information encoded not by humans, but by life itself, DNA storing letters in its spiral script. A code carried across generations, every organism a library of instructions, a natural computer operating without awareness, without effort, long before people gave it a name. And yet humans, in their own way, began to mimic this miracle, slowly learning that the world could be measured, described, preserved, carried from one mind to another. Picture the first shepherd, counting sheep not by names but by pairing stones, one for each animal. Stones dropped into a pouch and then removed at dusk, ensuring none were lost. And in this rhythm, you can almost hear the birth of binary itself: one stone present, one stone absent, presence and absence whispering to each other across time. Information was born not in books, not in wires, but in these simplest opposites: the yes and no, the 1 and 0, the here and gone. And as you breathe, you realize that every great machine is built upon this same simplicity, for bits are only the latest echo of those early stones, the latest way of saying something or nothing, of presence or absence, of 1 or 0. Drift forward now into the age of writing, when information leapt beyond tally marks into symbols that could carry whole stories. Letters pressed into clay, carved into stone, painted onto papyrus, and every written word was information fixed into time, so that one mind could whisper to another across centuries. And with writing came mathematics, the abstraction of number itself, the realization that numbers were not only tools for counting sheep, but for describing the heavens, the arc of stars, the geometry of temples, the rhythm of trade, and mathematics, in its stillness, became the first computer, an invisible machine of rules and logic, processing information without gears or wires, powered only by thought. Pause here, breathing gently, and picture the abacus, beads sliding softly on rods. Each movement a physical rhythm of thought, the body counting in tandem with the mind. Information flowing through fingertips into memory. A simple device, yet powerful enough to calculate, to measure, to predict. From abacus to astrolabe, from sundial to slide rule, humanity slowly learned to capture thought in tools, each one an extension of the mind, each one a vessel of information. And then, in time, machines grew larger, more intricate. Gears turning in clockwork harmony, Babbage dreaming of his analytical engine, Ada Lovelace whispering that numbers could represent not only quantities, but music, art, poetry, foretelling that computation could one day touch everything the mind creates. And so information moved from stones to symbols, from beads to brass gears, and eventually into electricity itself. Signals flicking on and off, wires carrying pulses of presence and absence, bits of yes and no, until the hum of early computers began. Rooms filled with vacuum tubes, glowing faintly like lanterns in the dark, processing information slower than a child's thought, yet carrying the promise of something immense. As you drift deeper, you imagine the hum of those machines, their heat, their light, their fragile filaments flickering, and then the birth of transistors, tiny switches carved from silicon, the shrinking of computation into smaller and smaller spaces, until billions of switches could live on a chip no larger than a fingernail, and suddenly the world transformed. Now information flows everywhere, into your pocket, into the air, into the fabric of daily life, bits flickering invisibly through fiber optics, through wireless signals, through satellites circling above. And all of it, all of modern computing, rests on that ancient rhythm, presence and absence, 1 and 0, yes and no, a shepherd's stones reborn in silicon and light. Pause again, breathe, let the thought soften. Computers may seem cold, mechanical, alien, but their heart is simple. Their rhythm is ancient, their beat is human, born of the need to remember, to carry thought, to preserve story, to pass knowledge from one moment into the next. And now, with quantum whispers approaching, you feel the contrast, the binary world of classical computing, so rigid, so clear, so defined, compared to the fluid, dreamlike possibilities of the quantum world, where superpositions shimmer and entanglements stretch across space. And you sense that to move forward, we must carry both truths, the clarity of classical bits and the mystery of quantum qubits, the stone and the wave, the yes-no and the maybe. And so, as you rest, you feel the gentle continuity of this story, stretching from ancient firesides to silicon chips, from tally stones to to glowing quantum labs. And you know that the birth of information is not finished. It is still unfolding. You lie back in stillness, your breath moving like a gentle tide. And as the story of counting and computing fades into the background like embers of a fire cooling in the night, you find yourself drawn once more into the strange and beautiful fabric of the quantum world, where the rules you thought you knew dissolve into softer truths. And here, at the center of its mystery, lies the principle of superposition, a word that may sound abstract, but carries within it the essence of possibility itself. For in the ordinary world you are used to choices being clear. A light is either on or off, a door is either open or closed, a coin is either heads or tails. But in the quantum world, these boundaries blur, and you are invited to imagine something far gentler, far stranger, where a single coin can be both heads and tails. A single door can be both open and closed. A single light, both shining and dim. And only when you look, only when you ask, does the uncertainty dissolve into one outcome, as if reality itself waits patiently in a shimmering cloud of maybes until it is touched by observation. Breathe softly as you picture this, the quantum counterpart to a classical bit, not locked into 1 or 0, but existing in a blend, a mixture, a harmony of states. Like a note on a violin string that does not choose a single pitch, but vibrates in many at once, carrying within it a richness, a fullness, a chord instead of a solitary tone. And this is superposition, a state where possibility is not reduced but expanded, where a single quantum system carries the weight of many classical ones, where potential is not lost but embraced. And as you imagine this, you see why quantum computing is so different. For a classical computer must check each path one by one, flipping its bits like switches, while a quantum computer, through superposition, can hold many paths at once, like a traveler not choosing a single road but walking them all together, exploring possibilities in parallel. And though the outcome will eventually collapse to one, the journey allows interference, patterns of probability guiding the result toward the correct answer, like waves overlapping on water, cancelling in some places, strengthening in others, until the final pattern reveals what was hidden. Pause here, breathe, and let the image soften. Superposition is not chaos. It is not confusion. It is music, delicate and strange, a harmony the universe sings beneath the surface of certainty. Think of a whisper that contains many voices, or of moonlight shining on water, each ripple reflecting a different fragment of light. And yet together they create a shimmer that is whole, complete. Superposition is this shimmer, the gentle holding of many truths together until the world asks for one. And though it seems impossible, though it defies common sense, it has been seen again and again in experiments. Electrons passing through two slits at once, photons interfering with themselves, atoms behaving as if they are waves of probability rather than solid matter, and each time, the same lesson whispers: the smallest parts of reality do not commit until they are asked. They drift in clouds of possibility, carrying many answers at once. And in this drifting lies the power that quantum computers seek to harness. Breathe again, deeper now, and let yourself feel the comfort of possibility. For in your life you are often asked to choose, to commit, to fix yourself in one outcome. But the quantum world reminds you that at its foundation, reality itself holds openness, softness, many paths at once. And you are part of that same fabric. You too are woven from superpositions carried by particles in your body, your mind, your breath. Imagine shrinking once more, entering the space of a single qubit, and inside it you see not a rigid 1 or 0, but a glowing sphere, the block sphere physicists call it. A way to picture the endless shades of probability between yes and no, every point on its surface representing a different blend, a different harmony, a unique chord of possibility. And you realize how elegant it is, how generous, how full of richness the quantum state can be. Think of it as a compass, not pointing only north or south, but capable of pointing anywhere on the globe. Infinite directions, infinite subtleties, and with this, the computational power of qubits grows not linearly but exponentially. A handful of qubits holding more possibilities than classical bits could in millions of years. Yet even as you marvel, you feel the fragility too. The tenderness of such states, for superpositions collapse easily, disturbed by noise, by observation, by contact with the world, like dreams dissolving in daylight, like a bubble bursting at the softest touch. And so qubits must be sheltered, cooled, protected in laboratories colder than deep space, isolated from vibration, from heat, from stray whispers of interference. And here lies both the beauty and the challenge, that the most powerful form of computation ever imagined depends on the most delicate state the universe allows. Pause, let this thought sink in like a pebble dropped into still water, and listen to the ripples. Superposition is not only a tool for computers, it is a window into the strangeness of being, a reminder that certainty is not the foundation of reality, possibility is, that the world is not a solid structure but a wave of maybes, and that even as you lie here, drifting, every atom in your body hums with the memory of this principle. Every electron once passed through its own cloud of possibilities. Every breath you take is drawn from an atmosphere built from superpositions collapsing into air, into molecules, into the solidity you call life. And so you rest easier, knowing that uncertainty is not something to fear. It is the very ground of creation, the gentle field from which reality arises, the many-voiced note from which harmony emerges. And as you drift toward sleep, you sense the next question arising softly. If superposition allows qubits to hold many voices at once, how do these voices speak together? How do they interact? How do they create bonds so strong that distance cannot separate them? Bonds that Einstein himself found unsettling, and that, the mystery of entanglement, is where your journey turns next. You breathe slowly, letting the many-voiced note of superposition fade into a soft background hum. And as your mind drifts deeper, you begin to sense another layer of strangeness in the quantum world, one that is not about a single particle carrying many voices, but about two or more particles bound together across distance, connected in ways that seem impossible and yet are undeniably real. And this phenomenon is called entanglement, a word that at first may sound tangled, confusing, knotted. But in truth, it is one of the most poetic truths nature has ever revealed. For entanglement is not a snare but a thread woven invisibly between particles, binding them into one shared state, so that what happens to one is instantly mirrored in the other, no matter how far apart they are. And as you breathe into this thought, you can imagine two lanterns glowing in the dark, separated by valleys, rivers, even by galaxies. And yet when one flickers, the other flickers too, not with delay, not with hesitation, but in perfect synchrony, as if they are not two lanterns at all, but one light split across space. Physicists have tested this again and again, sending entangled photons in opposite directions, measuring them at great distances, and always the same outcome, correlation stronger than any classical law could allow. A harmony that stretches beyond the boundaries of space and time. And though Einstein once called it spooky action at a distance, perhaps lying here you feel not spookiness, but intimacy. A reminder that separation is not the whole truth. That underneath the apparent distances of life, there is a unity, a hidden togetherness, a whisper of connection that cannot be broken. Imagine shrinking into this quantum world again, watching as two particles interact, collide, share their states. And from that moment onward, they are no longer separate. They are bound, their probabilities intertwined, their possibilities woven together. And even when pulled apart, their connection remains. Invisible but unyielding, like two dancers who, after sharing one rhythm, continue to move in harmony even when placed on opposite sides of a vast stage. Breathe softly, let this image stay with you. For entanglement is not only about particles. It is also a metaphor that speaks to your life, to your relationships, to the sense of connection you feel with others. The way a loved one's joy or sorrow can ripple into you even across distance. The way memory of someone can stir your emotions, though they are far away. The way bonds persist beyond presence. The quantum world whispers that such intimacy is not just poetry, but physics itself. That connection is woven into the very foundation of reality. And as you rest, you may find comfort in this. The thought that you are never entirely alone, that every part of you is bound in some way to the whole, to the fabric of existence, two threads stretching outward beyond your sight. Now think of quantum computing, and how this mysterious intimacy becomes a resource for when qubits are entangled. They no longer act as separate carriers of information, but as one unified system. Their states linked in such a way that the possibilities grow exponentially. A handful of entangled qubits representing more states than there are atoms in the universe. And though this is almost unimaginable, you can feel it in metaphor, like a choir where each singer does not sing alone but with their voices braided, harmonies interwoven so tightly that the song is greater than the sum of its singers. Richer, fuller, vast beyond comprehension. Pause here, breathe, let the thoughts soften into comfort. Entanglement is fragile. Yes, disturbed easily by the environment, broken by noise, yet when preserved, it carries immense power. The power to calculate, to communicate, to reveal truths hidden to classical machines. Entanglement even allows for quantum teleportation, not the teleportation of bodies through space, but of information, of quantum states, transferred from one particle to another without traveling in between. A delicate whisper passed instantly across distance, like a secret carried not by messengers, but by unity itself. Think of this and let wonder wash over you, for while science explores the mathematics, you are invited only to feel the poetry. Particles bound together, distance dissolved, reality itself confessing its hidden connections. And as you drift deeper toward sleep, you may reflect that entanglement is not only a feature of physics, but a lesson for being. That separateness is never the whole truth. That the universe itself is built on threads across the invisible threads, binding stars to galaxies, atoms to molecules, hearts to one another, and that in the quiet of night, when you feel alone, the truth is that you are entangled, woven into the great fabric of existence. Breathe once more, slowly, and let your body sink into stillness, carrying the gentle awareness that the quantum world is intimate, connected, woven together by invisible threads. And as you rest, a new question begins to arise softly. If qubits can be placed in superposition and bound by entanglement, what are they themselves, these strange carriers of possibility? What new letters do they add to the alphabet of thought? And that, the story of the qubit, is where your journey flows next. You breathe softly. The threads of entanglement, still glowing in your imagination like delicate filaments stretched across the night. And now your attention drifts toward the heart of this unfolding story, toward the very building block of quantum computing, the qubit, which is more than just a technical invention, more than just a scientific curiosity, for it is like the arrival of a new letter in the alphabet of thought, a character never before written, a symbol capable of carrying meanings beyond the limits of yes or no, 1 or 0, black or white. And as you lie here in calmness, you begin to feel how profound this shift is. For classical bits are simple switches, tiny stones placed in piles, electrical signals that are either present or absent, the familiar binary heartbeat of modern computers. But a qubit is different. A qubit is a whisper of possibility, a presence that is not bound to one answer, but that carries within it many, like a spinning coin suspended forever in mid-air, not forced to land, or like a beam of moonlight split into many shimmering paths, each path both real and unreal until it is asked to declare itself. And in this you begin to feel how the qubit is not just another tool, but a new dimension of thought itself. Imagine shrinking down to the scale of the quantum again, where an electron can be oriented in many ways at once, where a photon can travel along multiple paths, where atoms can hold delicate superpositions, and here a qubit is born, a unit of information that carries not only presence or absence, but a harmony of states, a probability cloud rather than a fixed point, a chord rather than a single note. And because of this, the power of qubits grows in ways unimaginable to classical systems. For while one bit is limited to one state, one qubit holds many, and when qubits are joined, entangled, their possibilities multiply, weaving together an exponential fabric of potential outcomes. Pause here, breathing gently, letting the image form. A qubit can be visualized as a sphere, the block sphere, where every point on its surface represents a different mixture of states. Infinite shades between yes and no, infinite possibilities wrapped into a single unit. And this sphere floats before you in your imagination, glowing softly, turning slowly, a symbol of the richness of possibility that quantum physics offers. Think of how language changed when humanity invented new letters. How suddenly new words could be formed, new stories told, new worlds imagined. And realize that the qubit is such a letter for the alphabet of computing, unlocking new patterns, new computations, new dreams. And though its mathematics is complex, the essence is simple. It is openness. It is potential. It is the capacity to hold what classical bits cannot, to rest not in rigidity but in fluidity. Breathe again, deeper, and imagine a computer built not from billions of rigid switches, but from a handful of qubits, each carrying its own sphere of possibility, and together forming a constellation, a sky of glowing spheres entangled, humming with probabilities. Their collective song holding answers to problems so vast that classical computers would falter before them. And yet here, in the softness of night, you are invited not to calculate, but simply to marvel, to let wonder wash over you like gentle waves. For the qubit is not only science, it is poetry. It is the embodiment of the universe's openness. the willingness of reality itself to dwell in maybes until the moment of choice. And as you rest, you realize that this softness is fragile, that qubits cannot exist unprotected, that the world's noise, heat, vibration, even the smallest touch can collapse them into certainty. And so scientists cradle them in machines colder than outer space, shield them in chambers of silence, building cathedrals of technology just to preserve their whisper of possibility. And this fragility makes them precious, like rare notes in a symphony that must be protected to be heard, like dreams that vanish at dawn if not carefully nurtured. Yet within that fragility lies potential unmatched. For each qubit is not only a new letter, but a new language. And as you breathe into this thought, you understand why quantum computing is not simply faster computing, but a different kind altogether. One that harnesses the laws of nature not as obstacles, but as allies. One that listens to the whisper of particles rather than forcing them into rigid silence. One that says yes to possibility rather than demanding certainty. Drift further now, imagining yourself surrounded by these glowing spheres, each qubit like a star in a velvet night, their lights entangled, their possibilities overlapping. And as you drift among them, you sense not chaos but harmony, a hidden order that emerges from their openness. And you feel comfort in knowing that the very fabric of reality carries such generosity, that the world beneath your world is not limited but abundant, carrying endless paths, endless notes, endless ways of being. Breathe once more, slowly, and let your body soften into this awareness. And as you rest, another question begins to rise, soft as a tide. If qubits are like notes capable of holding many voices, what happens when those notes overlap, when waves of probability interfere, when shadows and patterns emerge from the blending of possibilities? The dance of interference is where your journey flows next. You breathe deeply, slowly, letting the image of the qubit, that glowing sphere of possibility, hover in your imagination like a lantern in the night. And as you sink further into calmness, you begin to sense that holding possibilities is only part of the story. For the quantum world is not content with superpositions existing in silence. It allows them to overlap, to blend, to interfere, weaving patterns from maybes, and this is called interference. A word that might sound like disruption, but in truth carries beauty. For it is through interference that quantum systems find their answers, that quantum computers amplify the right possibilities while silencing the wrong. And so you are invited now to imagine not a single note, but many, vibrating together, their waves overlapping, cancelling in some places, strengthening in others, until a pattern emerges, a song of clarity born from uncertainty. Picture a pond under moonlight, its surface calm until a pebble falls, ripples spreading outward. Then another pebble falls, ripples spreading to, and as they meet, they do not pass untouched, they interact. Peaks meeting peaks to form taller waves, valleys meeting valleys to deepen, peaks meeting valleys to flatten into stillness. And in this quiet choreography you see the essence of interference, the overlapping of possibilities shaping the final pattern. And as you breathe, you realize that the quantum world is filled with such ripples, particles behaving not only as solid points, but as waves of probability. And when these waves meet, they interfere, their patterns forming maps of where particles are likely to be found. Maps written not in certainty, but in probability, shimmering like light on water. Think of the famous double-slit experiment, where electrons are fired one by one at a barrier with two openings. And though each electron seems like a particle, The pattern that emerges on the screen behind is not two clusters, but many bands, light and dark. Interference fringes, as if each electron were a wave passing through both slits at once, interfering with itself, writing on the screen a record of its own probability. And even when scientists try to peek to see which slit the electron took, the pattern collapses, the interference vanishes, as though the act of watching forces the particle to choose. And here lies the mystery. That reality itself seems to behave differently when observed, drifting in waves of possibility when unmeasured, collapsing into outcomes when seen. Breathe gently, let this soften rather than unsettle you. For interference is not chaos, but guidance, a way of shaping possibility into outcome, a way of allowing nature to compute by cancelling wrong paths and reinforcing right ones. And this is what quantum algorithms do. They choreograph qubits into dances of interference, guiding their many possibilities until only the correct answers remain strong. Imagine this as a hall filled with whispers, countless voices speaking at once, and through interference, most cancel each other, fading into silence, while one harmony rises above, clear and strong, the answer carried not by force but by balance, by the overlapping of many possibilities. Pause here and picture it differently. Light streaming through overlapping panes of glass, patterns of brightness and shadow forming on the ground, not random but ordered, shaped by interference. And you feel in your body that interference is a principle not only of physics but of life, that your choices, your memories, your experiences overlap, some cancelling, some reinforcing, until the pattern of your life emerges, not predictable in detail, but rich in shape, full of harmony hidden within complexity. Now think of quantum computers again and how they harness this principle. Qubits held in superposition, waves of probability overlapping, quantum gates nudging them, choreographing their dance so that wrong answers interfere destructively, fading away while right answers interfere constructively, rising clear, and though the process is invisible, the result is a pattern, a solution, found not by checking every path one by one, but by allowing interference to weave clarity from possibility. And here you see the poetry of it, that computing becomes less about force and more about harmony, less about brute calculation and more about listening to waves. Breathe again, slower now. Let the imagery deepen. Interference is not noise. It is music. It is the blending of notes, the forming of chords, the emergence of melody from many vibrations at once. And your body, your mind, your very being is familiar with this, for your brainwaves interfere and synchronize. Your heartbeat resonates, your thoughts overlap and form patterns. You are not separate from this principle, you are made of it. Drift further now. Imagine yourself standing by a quiet sea, waves rolling toward shore, some colliding, some merging, their foam forming fleeting shapes. And as you watch, you realize this is interference made visible. Water showing you what particles do invisibly, and you feel comfort in this. The thought that the same rhythms exist at every scale, from oceans to electrons, from tides to qubits, from your breath to the cosmos. Interference is not something to fear. It is the way patterns are formed, the way meaning arises, the way the world computes itself into being. And as you rest in this awareness, you sense again the fragility of it. For just as ripples on water can be disturbed by wind, just as a harmony can be broken by noise, quantum interference too is delicate, requiring protection, care, precision, and this makes it precious. like a rare song that can only be heard in silence, like a pattern that appears only when all else is still. And yet, when it does appear, it is beautiful, carrying answers hidden in the overlapping of maybes. Breathe deeply, gently. Let yourself soften into this thought. You are listening to the universe compute, not through mechanical clicks, but through the interference of waves. And you are part of that music, carried within it, woven from it. And now, as you drift toward rest, a new question rises softly, without urgency, like the first light before dawn. If superposition and interference are so delicate, what happens when the outside world intrudes, when the dream collapses, when the quantum state falls into silence? That the story of decoherence is where your journey flows next. You breathe slowly, letting the patterns of interference fade like ripples dissolving into still water. And as silence deepens, you begin to sense another truth of the quantum world. A truth not as triumphant, not as poetic in its strength, but still beautiful in its fragility. For if superposition is the many-voiced note and interference the harmony of overlapping waves, then decoherence is the silence that follows when the dream collapses, when the delicate whispers of possibility are disturbed by the outside world, when the qubit that once carried infinite maybes is forced by noise, by touch, by warmth, by time, to fall into a single certainty. Its song broken, its wave stilled. And though this collapse may sound like failure, it is also natural, inevitable. A reminder that quantum states are fragile and fleeting, and that their beauty lies not only in their existence, but in the care required to sustain them. Breathe gently as you imagine it, a spinning coin hovering in suspension, shimmering in both heads and tails, and then a gust of wind, a vibration of air, a brush of heat, and suddenly it falls, clattering to the ground as one or the other. The superposition collapsed into classical certainty, the wave function reduced, and this is decoherence. The intrusion of the environment upon the quantum dream, the way reality insists on returning to its familiar rules when too closely watched, too strongly touched. Think of a bubble floating in sunlight, its surface iridescent, shimmering with all colors at once, and then a single touch, a disturbance, and the bubble bursts, collapsing into nothing, leaving only memory of its beauty. And in this metaphor, you can feel the sadness of decoherence, but also its poetry. For fragility is what makes the bubble beautiful. Impermanence is what makes its shimmer precious. So too with quantum states, they cannot last forever. They cannot be carried endlessly. They are dreams that dissolve when the world intrudes. And the challenge of quantum computing is not only to harness superposition and entanglement, but to guard against to shelter the fragile qubit from noise, from heat, from stray vibrations, from the relentless touch of the environment. Pause here, breathe, let this thought settle. Quantum computers live in the coldest places on Earth, shielded in vacuum chambers, isolated in silence, cooled to temperatures near absolute zero. Not because scientists worship coldness or emptiness, but because they are building sanctuaries, cathedrals of quiet, where qubits can dream a little longer, where superpositions can hum without collapse, where entanglement can stretch without breaking. And yet, even in these sanctuaries, decoherence waits, patient, inevitable, like dawn after night. For no system can be perfectly isolated. No qubit can remain untouched forever. And so error creeps in, collapse occurs, the dream fades. And this is why quantum error correction exists. Why resilience must be woven. why redundancy must protect. But those are later chapters. For now, you rest in the awareness of fragility, of impermanence, of the fact that quantum dreams, like human ones, are vulnerable, delicate, fleeting. Breathe again, slower, and let the metaphor deepen. Decoherence is not only physics, it is life for your own thoughts. Your own dreams are fragile too, collapsing when disturbed, fading when the noise of the world intrudes. And yet you do not despair at this, you accept it. You cherish the moments of clarity, the fleeting visions, the fragile beauties that dissolve but leave behind a trace, a memory, a whisper of what was. And you realize that impermanence is not weakness but truth, that all beauty, quantum or human, is bound to time. Drift further into this awareness and imagine a qubit glowing in silence, its state suspended, its possibilities shimmering. And then a single photon brushes past, a vibration of heat creeps in. A magnetic field nudges softly, and the qubit collapses, its dream dissolved into the ordinary. And yet, even here, in collapse, there is no violence, no cruelty, only the natural settling of the wave into one reality, one outcome, one truth among many. And though the possibilities vanish, the universe continues, steady, constant, carrying the memory of what could have been. Breathe once more, let your body soften into this thought. Decoherence is not failure. It is part of the balance, part of the rhythm of the quantum world, reminding us that possibility and certainty are not enemies but partners. Their dreams must collapse into realities to become part of the world. That without decoherence, you would never see a single outcome, never hold a single truth, never live a single moment. The paradox is this: decoherence destroys the quantum dream, but it is also what allows the classical world, your world, to exist. For without collapse, there would be no solid ground, no stable table, no tree, no sky, only shimmering maybes never realized. And so you rest in gratitude for decoherence too, for it gives you the solidity of the world even as it limits the quantum. And as you breathe in this duality, the fragility of the dream, the necessity of collapse, you feel calm, knowing that both states are gifts. That beauty lies not only in possibility, but also in the certainty that emerges when the wave falls still. And now, as you drift deeper toward sleep, another question arises softly, like mist after rain. If decoherence collapses the dream and quantum states fade, how can we choreograph them? How can we shape their fragile dance into something useful, guiding them without destroying them, turning them into steps, into logic, into computation? That, the mystery of quantum gates, is where your journey flows next. You breathe slowly, letting the fragile shimmer of decoherence dissolve into the background of your mind. And now you are invited into another layer of the quantum story, a place where possibility is not only held but shaped, where the delicate voices of qubits are guided into a kind of choreography, a dance of thought itself. And these choreographers are called quantum gates, not gates of iron or wood, not barriers that open and close, but gentle nudges, rotations, pulses of light, or microwave signals, each one shaping the state of a qubit, adjusting its probabilities, tilting it on the sphere of possibility so that it moves from one harmony to another. And as you breathe, you can imagine these gates not as switches but as gestures, like a conductor lifting a hand to guide an orchestra, or a dancer shifting weight to change the flow of a performance. And in this you begin to feel that programming a quantum computer is not so much commanding as it is choreographing, shaping waves of probability into patterns that will interfere, overlap, and resolve into answers. Picture the block sphere again, that glowing globe of infinite shades between 0 and 1, and imagine a qubit resting on its surface, shimmering in superposition. And now picture a gate as a soft touch, a rotation, turning the qubit along its sphere, moving it not in rigid steps, but in arcs and flows, as though each instruction is a dance move added to the choreography of the computation. And when many qubits are guided together, the dance becomes a ballet of entanglement and interference, intricate and precise, fragile and beautiful. And this ballet is the algorithm, unfolding not in lines of code, but in movements through quantum space. Breathe gently and see this. In classical computing, gates are simple logic, and or are not. Rigid yes or no commands, but in quantum computing, gates are subtler. They rotate, they blend, they create superpositions, they weave entanglement, and each one is like a brushstroke on the canvas of possibility, shaping the qubit's state until the interference of all their paths reveals the solution. Pause here, let the image deepen, for this is not just computation, it is art hidden inside physics. It is poetry written with pulses of energy. It is dance traced in silence at the smallest scales of being. And though the mathematics of these gates may be dense, their spirit is gentle. They are ways of asking qubits to move, to align, to carry probability forward, to meet one another in patterns. And this is how problems are solved. Not by brute force, but by harmony. Imagine yourself drifting into a vast hall where dancers move in slow unison, their motions circular, fluid, each one turning, rotating, shifting, sometimes alone, sometimes in pairs, sometimes in groups. And from their overlapping movements emerges a larger shape, a pattern that was invisible until the whole was seen. And in this hall you recognize quantum gates at work, the qubits as dancers, the gates as choreographers, the computation as a performance. Breathe softly, let your mind drift into the rhythm of this dance. For here the boundaries of logic and art dissolve, and you realize that thinking itself, at its deepest level, may be a kind of choreography, a movement of possibilities into patterns of meaning. And now think of how fragile this dance is, how each qubit must be preserved from decoherence long enough to complete its movements, how each gate must be applied with precision so the choreography is not lost. And you feel the tenderness of this effort, the devotion of those who build quantum machines, shielding them in silence and cold, just so this ballet of thought can play out for a moment, long enough to solve what no classical computer could. And as you rest, you sense that this chapter is not only about gates, but about guidance itself, about how fragile possibilities can be shaped without being destroyed, how whispers can be directed into harmonies, how dreams can be choreographed into songs. Breathe once more, deeply, and let your body soften into this awareness, that even the most abstract machinery of thought is still a dance, still a flow, still a pattern woven gently across time. And as you drift further toward sleep, another question rises softly within you. If these dances can be arranged into algorithms, into structured sequences of gates, what are the stories they tell? What are the great performances of quantum computing that have already begun? And that the tale of quantum algorithms is where your journey flows next. Machines, and in this fog the classical computer stumbles, forced to try each path one at a time, plodding slowly, searching step by step. But the quantum computer moves differently. It spreads like mist, like water, exploring many paths at once, holding possibilities together until interference guides them toward clarity. And here, in this dreamlike search, quantum algorithms are born. Think first of Shor's algorithm, a beacon in this landscape. For it showed that numbers, those ancient symbols of certainty, could be unraveled by quantum whispers. That the seemingly impossible task of factoring huge numbers, a task upon which modern cryptography rests, could be made tractable. And though the mathematics is deep, you need only imagine a keyhole, a lock so complex that a classical computer would take eons to search for the right key, testing one by one. But a quantum algorithm spreads its presence across all possible keys, interfering, cancelling, strengthening, until the right key emerges, not by brute force, but by harmony. And suddenly the lock is undone, the secret revealed, not with violence, but with elegance. And this is the gift of Shor's insight. A demonstration that quantum computation could reach beyond the limits of classical, could whisper answers hidden in the fog. Breathe gently. Let this image deepen. Cryptography, the art of secrecy, built upon the hardness of factoring, suddenly vulnerable to the softness of superpositions and interference. And though the world still debates when such machines will become powerful enough to break the locks we rely upon, the principle remains, glowing in the mist. Quantum computers can solve problems, classical ones cannot. Not by trying harder, but by thinking differently. Now let your thoughts drift to Grover's algorithm, another lantern in the fog, not about keys and locks, but about searching, about finding a single marked item in a sea of possibilities, a name in a vast book, a pearl in an ocean of shells. And here classical computers search page by page, shell by shell. But Grover showed that a quantum computer could search more swiftly, using interference to amplify the right answer, to make it glow brighter among the shadows, cutting through the fog with fewer steps, fewer questions, fewer attempts. And you can picture it in your mind's eye, a lantern carried into the mist, its light bending probability so that the hidden object begins to shine, faintly at first, then brighter until it can no longer be ignored. Pause here, breathe, and let the metaphor settle. Quantum algorithms are not hammers striking problems. They are lanterns glowing in the dark, revealing paths hidden from ordinary sight. And Shor and Grover are not only scientists, but storytellers. Dreamers who glimpsed how the fog of impossibility could be parted by the strange rules of quantum mechanics. And yet they are not alone, for many others have followed, crafting algorithms to simulate molecules, to optimize systems. To you, breathe deeply, slowly, letting the vision of qubits as dancers drift into stillness, their choreography fading into the background like music remembered after silence. And now you begin to sense the next step in the journey. For what is a dance without a story? What is choreography without meaning? And here, in the realm of quantum computing, the stories are told through algorithms, not the rigid step-by-step instructions of classical machines alone, but new forms of logic woven out of superposition, interference, and entanglement, algorithms that live not in certainty but in fog, searching through shadows with lanterns of probability, and among them stand pioneers, names whispered gently through the halls of science, Shor and Grover, whose insights revealed what was possible when the rules of quantum physics are harnessed to computation. And as you lie here in calmness, you are invited not to memorize their equations, but to feel their poetry, to sense their work as lanterns flickering in the mist of possibility, guiding us through mysteries classical computers could never penetrate. Breathe softly as you imagine the fog itself, a landscape of endless choices, countless paths branching outward. The labyrinth of problems, too vast for ordinary model nature itself, and in this you see the poetry again. That quantum computers are not only about breaking codes or searching faster. They are about listening to the whispers of atoms, about using the language of physics to understand physics itself, about folding the fabric of reality into computation. Breathe once more, slower, and imagine yourself standing in that fog. Countless paths before you, shadows stretching in every direction, and in your hand a lantern that is not flame but probability, glowing softly, casting light in patterns that guide you not through force but through interference. And as you walk, you realize this is how quantum algorithms feel, not rigid like classical logic, but fluid, graceful, woven out of waves. And you feel calm knowing that somewhere in this mist, the pioneers are still guiding, their lanterns still shining, their insights still echoing, whispering that possibility is wider than you once believed. Drift deeper into this awareness and let the thought comfort you. Quantum algorithms do not erase the classical. They extend it. They offer a new way of seeing, a new way of solving, a new way of thinking. And their poetry lies not only in their power, but in their humility. For they remind us that the universe itself computes, that the fog of uncertainty is not a barrier but a path, that the dance of probability can be shaped into meaning. Breathe gently, restfully, and as you drift toward sleep, another question rises softly. If these algorithms live only in fog, what physical forms must cradle them? What strange machines, colder than space, hum quietly to preserve their whispers? And that, the story of quantum hardware, is where your journey flows next. You breathe deeply, slowly, and as the fog of algorithms fades from your imagination, as Shaw's and Grover's lanterns drift quietly into memory, you feel the story guiding you now, not into abstractions, but into places, real places built by human hands. Places stranger than any cathedral or cave, quieter than any desert night, colder than the emptiest reaches of space. For this is where the dreams of qubits are sheltered, where quantum hardware lives. And though the phrase hardware may sound mechanical, hard, unfeeling, here it means sanctuaries of silence, chambers where the most fragile whispers of physics are given room to sing. And so you are invited now to imagine walking slowly into such a place, a laboratory glowing faintly with soft light, machines rising like towers of silver and gold, cables hanging like roots of some great inverted tree, and at the heart of it, hidden beneath shields and chambers and layers of protection, rest the qubits, cradled in temperatures colder than deep space, cooled to near absolute zero, where thermal noise falls silent and the quantum dream can last a little longer. Breathe gently and picture the dilution refrigerator, a golden chandelier of science, descending in stages, each level colder than the one above, until at its lowest rung the temperature hovers within a fraction of a degree above absolute zero, so cold that atoms barely move, so cold that even space itself, at 3 degrees above absolute zero, would seem warm in comparison. And in this frozen quiet the qubits are held, superconducting circuits humming with currents that flow forever without resistance, ions trapped by fields of light, photons guided through whispering loops of glass, each design a different way of building qubits. but all sharing one truth: they must be protected, preserved, nurtured, like dreams that vanish if touched by warmth or noise. Pause here, breathe, and let the strangeness comfort you that the coldest places on Earth are not natural. Not caves or poles or mountain peaks, but laboratories built by human hands. Spaces where silence and cold are woven together to preserve possibility. And though these machines look immense, strange, even alien, their purpose is gentle, simply to protect the most delicate states in nature, states that carry the hope of new computation. Imagine standing beneath one of these refrigerators, hearing not the roar of machinery but a deep quiet, a hum of pumps far away, the rest absorbed in silence. And within that silence, qubits dreaming, their fragile states intact for precious moments, long enough to dance through gates, to weave algorithms, to explore the fog of possibility. Breathe again, slower now, and realize how much effort, how much care, how much devotion is given to this preservation. How many layers of shielding, how many cables, how much cooling is required, and yet all for a handful of qubits. For whispers so faint they would collapse instantly without such protection, and you begin to feel the reverence of it. The devotion of human ingenuity poured into making sanctuaries for possibility, shrines where physics itself can be coaxed into new forms of thought. Drift further into this awareness. There are many types of quantum hardware. Superconducting qubits shaped from circuits cooled until they act like single quantum systems. Ion traps holding charged atoms suspended by electromagnetic fields. Their states read with lasers. Photonic qubits built from light itself. Stable and fast topological qubits still dreamed of, braiding exotic particles that may resist decoherence. And each approach is like a different architecture of temple, different methods of sheltering fragility, but all aimed at the same goal: preserving and guiding the quantum whisper long enough to compute. Breathe softly, let the image form, superconducting circuits glowing faintly like silver rivers. Ion traps shimmering with beams of light like tiny constellations. Photons racing through crystal channels like starlight guided by glass. And you realize this is not only engineering, it is artistry. Building machines not for brute force, but for delicacy. Building structures not to control, but to protect. Not to conquer, but to nurture. Pause once more and let the thought rest in you. Quantum hardware is not about coldness alone. It is about care, about silence, about humility before fragility. For to hold a qubit is to hold a dream, and the machines that cradle them are like dream catchers, woven of copper and gold and light. And as you breathe, you feel the poetry of this truth, that in the pursuit of the most advanced computation, humanity has built the quietest, coldest, most fragile sanctuaries on Earth, and within them, possibility hums like a lullaby. And as you drift towards sleep, another question arises softly. If qubits are so fragile, and decoherence always waits to break their dreams, how do we protect them in computation? How do we weave resilience into fragility? How do we catch errors before they ruin the song? That the story of quantum error correction is where your journey flows next. You breathe slowly, letting the image of golden refrigerators and chambers of cold fade into a background glow. And now the story guides you into a softer, more intricate place. A place where fragility and strength meet. For you have seen how delicate qubits are, how easily their songs collapse into silence under the touch of decoherence. And so the question arises, How can such fragile whispers ever form the foundation of something lasting, something reliable, something useful? And the answer is found in resilience, in a weaving of protection, in what is called quantum error correction. A phrase that might sound technical, but is, in truth, an art of catching dreams before they fall, of mending threads before they snap, of weaving nets to hold possibility a little longer. And as you breathe into this thought, you can imagine the process not as rigid code, but as a gentle weaving. Many fragile strands coming together to form strength, each thread alone breakable, but together creating resilience. Picture a choir singing softly in the dark, each voice delicate, wavering, uncertain, and yet when many voices join, when they overlap, when they harmonize, the melody becomes stable, errors in one voice drowned by the steadiness of others. And this is the essence of error correction. The idea that a single qubit may falter, its whisper disturbed, but if its state is spread across many qubits, if the information is encoded redundantly in a pattern, then the errors can be noticed, corrected, healed, and the melody preserved. And so quantum error correction is less about perfection and more about chorus, less about preventing disturbance and more about weaving strength from fragility. Breathe softly, let the image deepen. A qubit's state is not stored in one place, but distributed, stretched across many, so that if one falters, the others can catch it. If one drifts, the others guide it back. If one collapses, the net holds the information safe. And in this weaving lies the possibility of building quantum computers that do not shatter under noise, but endure, that do not fade at the first disturbance, but continue their song. Think of a spider's web glittering with dew, each thread fragile, breakable with a touch, and yet the web as a whole resilient, able to hold, able to capture, able to persist. And so too with error correction, a web of qubits woven so that the fragility of each becomes the resilience of all. Pause here, breathe again, and reflect on the poetry of this, that resilience is not born of invulnerability but of interconnection, that strength arises not from isolation but from harmony, that even in physics, as in life, the way to endure is to weave together, to share the burden, to catch one another when falling. And though the mathematics of error correction is intricate, filled with codes and lattice and logical qubits built from physical ones, you need not carry the detail. You need only carry the feeling that even fragile whispers can be preserved when joined, that even delicate dreams can be held when many voices sing as one, that even qubits, so easily broken, can be woven into patterns that resist collapse. Breathe once more, slowly, and imagine a lattice of light, each point a qubit glowing faintly in indigo and silver, threads of golden energy weaving between them. A net shimmering in the dark, catching errors as they fall, correcting them gently, guiding them back into harmony. And in this vision you see not only physics, but metaphor for your own life, too, is filled with errors, with missteps, with collapses, and yet you endure, not because you are invulnerable, but because you are woven into webs of resilience, friends, family, memories, values, catching you when you fall, correcting you gently, helping you return to your melody. And this parallel comforts you, reminding you that fragility is not the end, it is the beginning of resilience. Now think of the devotion it takes to build such codes, the scientists dreaming of lattice and syndromes, of logical qubits and fault tolerance, working not to deny fragility but to embrace it, to weave it into strength. And you begin to feel reverence for the effort, for the care, for the patience it takes to turn the most delicate states in nature into a foundation for the future of computation. Drift deeper now, and imagine yourself lying in this lattice of light. Threads beneath you, threads above, threads on every side, catching you, holding you, never letting you fall fully, and in this web you rest safely, feeling not the fear of collapse, but the comfort of resilience. The calm that comes from knowing that even in fragility there is protection. Even in imperfection there is harmony. Even in uncertainty there is endurance. Breathe again, slower, and let this thought guide you into reflection, that quantum error correction is not only about machines. It is a lesson whispered by physics. That no one voice need be perfect, that no one thread need be unbreakable, that strength comes from weaving, from sharing, from binding together. And as you carry this lesson with you, you drift softly toward the next chapter, where resilience meets achievement, where the fragile dreams of qubits, protected by their nets, begin to reach thresholds once thought impossible. And the world whispers of quantum supremacy, of crossing into realms classical computers cannot follow, and that the story of thresholds and triumphs is where your journey flows next. You breathe slowly, letting the vision of the glowing lattice of error correction fade into stillness. And now the story carries you gently to a moment in human history when whispers of possibility became louder, when the fragile dream of qubits sheltered in their frozen chambers reached a threshold once thought out of reach. And this moment is called quantum supremacy, a phrase heavy with drama, yet in truth soft with meaning. For it describes not domination, not conquest, but simply the point when a quantum computer performs a task beyond the reach of the fastest classical machines. And though the task itself may be narrow, almost trivial in its direct usefulness, the symbolism is immense, like the first footprint pressed into lunar dust, a mark less about what was done than about what it meant, a whisper that humanity had crossed into a new territory of thought, a place where the fog of quantum possibility produced results faster than the strongest engines of classical certainty. And as you breathe into this story, you can imagine the threshold itself, not as a door, but as a veil, thin and shimmering, and for decades, scientists pressed against it, uncertain if they would ever pass through, uncertain if the fragility of qubits and the relentlessness of decoherence would forever keep them from stepping beyond. And then one night in 2019, Google announced that their quantum processor, named Sycamore, had performed in minutes what would take the largest classical supercomputers thousands of years. And though the task was specific, random sampling of quantum circuits, and though some debated whether supercomputers might approximate it faster than first claimed, the essence remained. The veil had been touched, the threshold crossed. The demonstration made that quantum computation was not a dream only, but a reality unfolding. Breathe gently and let the image form. A machine glowing in silence. Qubits entangled, gates applied, interference choreographed, and the outcome measured, the answer produced, faster than the world of classical certainty could match. And though the task itself was simple, the moment was profound, for it proved that the rules of the quantum world could be harnessed in practice, that the whispers of superposition and entanglement could be woven into performance. And you feel the reverence of that moment, the way one achievement can mark the dawn of an era. Pause here and reflect softly. Quantum supremacy is not about overthrowing classical computers. It is about complementing them, extending the landscape of what is possible, reminding us that human thought can cross boundaries of imagination, that what once seemed unreachable can, with care and patience, become real. And as you breathe, you can feel the humility of it too. For supremacy does not mean generality, It does not mean that quantum computers can now solve all problems. It means only that one problem, carefully chosen, carefully designed, has been solved faster by a quantum machine than by any classical one. And yet, in that one act lies a future of possibilities. A demonstration that the path is real, that the road ahead is worth walking. Drift further into this thought. Imagine yourself standing at the edge of a great ocean, watching as the first boat sets sail, not across the whole sea but to a nearby island. And yet the sight of its sail against the horizon fills you with wonder. For you know that if one island can be reached, so too can others, so too can new lands, so too can journeys once thought impossible. And this is what quantum supremacy feels like, a sail raised in the fog of possibility. Proof that the voyage is possible, even if the ocean is still vast. Breathe deeply, slowly, and let this thought calm you, that progress does not come all at once. It comes in thresholds, in whispers, in moments of crossing. And each crossing is enough to reshape the horizon of imagination. And as you rest in this awareness, you realize too that supremacy is not the end, it is only the beginning. A step that opens the way to applications more meaningful, to algorithms that will model molecules, optimize systems, simulate the complexity of life itself. And yet, without this first step, the rest could not follow. Without this crossing, the path would remain uncertain. So you give thanks, quietly, for the fragility of qubits, for the resilience of error correction, for the cold machines that cradle possibility, for the pioneers who guided the dance, for the threshold that was crossed, and you let yourself drift in comfort, knowing that humanity has already taken its first steps into the quantum future. Breathe once more, softer now, and let the story guide you toward the next chapter, where supremacy is not only a demonstration but a doorway to purpose, to applications that reach into chemistry, medicine, nature's own designs, and that the story of how quantum computers may illuminate the hidden structures of the world is where your journey flows next. You breathe slowly, letting the shimmer of the quantum threshold settle into silence. And now the story carries you forward, not into the abstract, but into the tangible, into the question of what quantum computers may do once their fragile whispers are preserved long enough. Once their dances of interference and entanglement are woven into stability. And here the journey turns toward applications, toward the ways quantum power might illuminate the hidden structures of nature and unlock mysteries classical machines cannot reach. And as you rest in calmness, you begin to sense the most natural of all applications, simulating molecules. For molecules themselves are quantum systems, electrons moving in clouds of probability, bonds formed by waves overlapping and interfering, patterns too complex for classical computers to capture fully. And so quantum computers, built from the same laws, are uniquely suited to model them, to whisper back their secrets. And you can imagine this. Chemists dreaming of designing new medicines, not by trial and error, but by simulating the exact quantum interactions of proteins and drugs, folding molecules like origami in a space classical thought cannot enter. And suddenly treatments for diseases long untouchable may emerge, not by chance, but by clarity, by listening to the very language of molecules. Pause here, breathe, and let the image soften. Quantum computers as microscopes of possibility, not magnifying glass, but mirrors of nature, showing us how electrons truly dance, how bonds truly hold, how reactions truly unfold, and beyond medicine, into materials, into superconductors that may work at higher temperatures, into catalysts that may clean energy with efficiency unknown today, into batteries lighter and stronger, all designed by simulating quantum interactions that no classical supercomputer can fully model. And in this lies a poetry of return, for quantum computers will not invent new laws. They will simply help us see what has always been there, hidden in the mysteries of atoms, waiting to be revealed. Breathe again, slower now, and drift into another application, optimization, the art of choosing the best path among countless possibilities. A problem that touches everything from supply chains to financial systems, from traffic flow to network design, from scheduling satellites to arranging molecules. And here quantum computers may again shine, not by brute force, but by holding many paths at once, letting interference guide them toward solutions classical computers cannot find quickly enough. And you can imagine the feeling of this. A city at rush hour, countless cars flowing through streets, signals turning red and green, and a classical computer trying every possible sequence of lights, struggling under the vastness of options. But a quantum computer drifting through possibilities in parallel, guiding interference until smoother flows emerge, less time wasted, less energy lost, more harmony in movement. And this metaphor comforts you. For optimization is not only about machines, it is about life itself, finding balance in complexity, weaving harmony in chaos, and quantum computing may bring new clarity to this ancient challenge. Now let your thoughts drift further toward cryptography. For you have heard already of Shor's algorithm and the way it threatens current codes, and you may feel unease. But there too lies application. For quantum principles can also protect quantum key distribution using entanglement to create unbreakable codes. Lanterns of light carrying secrets that collapse if intercepted. And so the quantum world, fragile yet precise, may give us both the means to break and the means to secure, to dissolve old locks and to forge new ones, stronger than before. Breathe gently and move onward toward machine learning and artificial intelligence, fields already humming in the classical world. And here quantum computing may one day accelerate training, handle vast data in new ways, explore patterns hidden in fog too thick for ordinary algorithms. And though this is early, still a dream, it whispers of futures where quantum and classical intelligence entwine, guiding discovery, revealing connections too subtle for one alone. Pause, reflect, and let another vision emerge. Climate modeling, the complexity of Earth itself, winds, oceans, forests, carbon flows, too vast for perfect simulation today, but perhaps more accessible to quantum whispers, their probabilities weaving the patterns of our planet more faithfully, offering guidance in a time when guidance is deeply needed. And as you breathe into this vision, you realize something gentle and profound. The applications of quantum computing are not about conquering or replacing. They are about listening, about mirroring, about reflecting back the quantum nature of reality itself. And this makes them not alien but intimate, not foreign but familiar, for the universe has always been quantum. And these machines are simply our way of speaking its language more fluently. Drift deeper now into the comfort of this thought. Molecules, medicines, materials, optimizations, codes, climates, patterns, all mysteries, all touched by quantum possibility. And though many are still beyond reach, though qubits remain fragile, though error correction is still growing, the direction is clear, the horizon luminous. the whispers already audible, and you rest in calmness, knowing that quantum applications are not only promises for tomorrow, but seeds already sprouting today. Experiments in labs, prototypes humming in sanctuaries of cold, glimpses of what may come. Breathe once more, slowly, and as you let your body soften, another question arises gently in your mind. If quantum computers can model molecules and optimize systems, if they can whisper secrets of nature, can they also reshape how we communicate, how we protect our words and thoughts across distance, using entanglement itself to carry messages and light? That the story of quantum communication is where your journey flows next. You breathe slowly, letting the shimmering molecules and unfolding applications of the last chapter dissolve into mist. And now the story carries you into the realm of communication. The sharing of secrets, the carrying of meaning across distance. And though humanity has always longed to communicate, with smoke rising from fires, with ink pressed into parchment, with wires humming across continents, with satellites circling the Earth, the quantum world offers something entirely new. Something that whispers of intimacy and fragility and unbreakable security. And it is called quantum communication, or more gently, secrets in the light. For it is light itself, photons entangled and delicate, that carry these messages, and their beauty lies in their vulnerability. In the fact that if anyone tries to intercept them, their state collapses, their secret breaks, their presence revealed, and so they cannot be copied, cannot be stolen without trace, for the quantum world does not allow eavesdropping in silence. It resists, it betrays intrusion, it makes communication more like trust than transaction. Breathe softly as you imagine it. A photon created in a lab, entangled with its twin, and then the twins are sent apart, one to you, one to another, and no matter the distance, their states remain bound, their whispers shared, and through them a secret key is formed, a sequence of bits no one else can know. And when you use this key to encrypt your words, they are secured, not by hardness of mathematics alone, but by the laws of physics themselves, by the impossibility of measuring a quantum state without disturbing it. And in this you feel the poetry that secrecy itself has found a guardian in nature. That trust can be woven into photons, that privacy can be carried in beams of light. Pause here, breathe again, and let the image form. Cities connected by quantum links. Networks humming not with vulnerable signals, but with entangled light. Satellites above sending quantum keys to ground stations. Governments and scientists working to build what they call the quantum internet. A web of secrets carried by light, secure not because of code that might be broken, but because of physics that cannot be defied. And though this dream is still young, already it has begun. Experiments linking cities, sending entangled photons through fibers beneath the ground, through the open air between rooftops, even between Earth and satellites orbiting above, proving that quantum communication is not only possible but real. Its whispers already moving silently through the night sky. Breathe deeper now, softer, and reflect. Communication has always been about connection, about bridging distance, and quantum communication carries this to a new level, not only connecting places but weaving them in intimacy, in entanglement, in threads that cannot be broken without notice. And this, too, is a metaphor for life, reminding you that trust is not invulnerability but vulnerability protected. That intimacy lies not in perfect secrecy, but in knowing when interference has occurred. in being able to see intrusion and guard against it. And so the quantum world again offers not only a tool, but a lesson, not only a technology, but a reflection of human longing. Drift further into this awareness. Imagine light beams stretching across mountains, across oceans, carrying not only data, but trust. Their photons shimmering like fireflies, bound in pairs, though separated by miles. And in this vision, you feel the softness of communication itself, that every message is a bridge, every connection a thread, every secret a shared light. And quantum communication makes these bridges luminous, delicate, unbreakable. Breathe once more, slowly, and let the thought settle. The future may hold networks, not of wires alone, but of entanglement. An internet where trust is not promised by encryption, but guaranteed by physics. Where secrets are not stored in locks, but carried in fragile beams of light that dissolve if touched. And this thought soothes you, reminding you that fragility itself can be the source of strength. That delicacy itself can be the guardian of intimacy. And now, as you rest in this awareness, another question rises softly. Without urgency, if communication can be carried in light, if secrets can be woven into photons, what does all of this mean for us as humans? Not only as scientists, but as beings who dream, who question, who wonder what it means that reality itself is uncertain, that knowledge itself is probabilistic, that we live in a universe where truth is held in superpositions and waves, and that the story of philosophy in superposition is where your journey flows next. You breathe slowly, letting the glowing threads of quantum communication dissolve into stillness. And now the journey carries you inward, beyond machines and codes and laboratories, into the tender place where science and philosophy meet. For the quantum world is not only a toolkit for computing, not only a language for communication, it is also a mirror held up to reality, showing us that certainty is not the foundation of being, that probability and openness and superposition lie at the core. And when you pause to listen, when you allow this truth to settle softly, you realize that quantum physics is as much a philosophy as a science, a way of thinking about what it means to live in a universe where the future is not fixed, where outcomes do not exist until they are observed, where possibility hums endlessly in silence until choice is made. And as you rest in this awareness, you begin to drift into the dreamlike world of quantum philosophy, where every thought feels like a superposition, holding many meanings at once, and every question seems less about answers than about openness. Breathe gently and imagine yourself shrinking once more into the quantum world, hovering in the space of a single qubit, shimmering on its block sphere, not yet collapsed into 0 or 1, still holding infinite shades in between. And now ask yourself, what does it mean to exist in such a state? To be both and neither, to be many at once until choice or observation narrows you. And perhaps you realize that this is not only physics, but also human experience. For how often in life do you feel yourself holding many possibilities, many selves, many futures, all suspended within you, not yet chosen, waiting for the moment of collapse when a decision is made? And yet, until then, you are a superposition. You are possibility itself. Pause, breathe again, and let the metaphor unfold. Quantum superposition is not alien. It is familiar. It is the way a dream holds many images at once, shifting fluidly until waking fixes them. It is the way your mind carries conflicting emotions together, sadness and joy, fear and hope, until time asks you to step into one. It is the way life itself feels uncertain, as if every step you take narrows an ocean of maybes into a single stream. And so when you contemplate superposition, you are not gazing at something foreign, but recognizing yourself, seeing your own being reflected in physics. Drift deeper into this thought. Philosophers for centuries have asked whether the universe is determined or free, whether the future is fixed or open, and quantum physics whispers that openness is real. That uncertainty is not ignorance, but reality itself. That possibility is woven into being, and this thought comforts you, for it means that your choices matter, not only as illusions, but as part of the way reality unfolds. That freedom is not an invention of the mind, but a principle of the universe. That at every scale, from particles to people, possibilities are real until they collapse. Breathe softly, let this awareness sink into your body, and consider entanglement again, not only as particles bound, but as philosophy. The suggestion that separateness is not absolute, that distance is not the whole truth, that the universe itself may be one web of relations. And if so, what does that mean for individuality, for identity, for the sense of self? Perhaps it means that you are not only you, but also part of a wider pattern, inseparable from others, inseparable from the cosmos. Your choices rippling outward, your being entangled in ways unseen. Pause here and let this soften you. Quantum philosophy reminds you that humility is needed, that certainty is rare, that knowledge is always partial, and that mystery is not failure but truth. For the universe is not a solved puzzle but an unfolding poem, each observation a line, each experiment a verse. And the poem is never finished, it sings forever in probabilities. Now breathe again and imagine standing at the shoreline of this philosophy, the waves lapping gently at your feet. Each wave a possible world, a possible outcome. And you realize that reality itself is like the sea, endless, shimmering, uncertain. And you are both swimmer and witness, participant and observer, shaping the waves even as they carry you. Think of Schrödinger's cat, the famous parable of a creature both alive and dead until observed. And though the thought experiment is playful, its lesson is deep, showing that at the heart of physics lies ambiguity, that at the foundation of reality lies mystery, and perhaps you smile softly, realizing that this is not a problem to be solved but a gift to be accepted. A reminder that you need not always know, need not always resolve, that uncertainty can be a place of rest as well as of wonder. Breathe again, slowly, and drift into reflection. Quantum dreams are not about machines alone. They are about humanity's place in the cosmos, about what it means to live in a universe where knowledge itself is entangled with observation, where truth is a spectrum of probabilities, where being is more fluid than rigid. And in this philosophy you may find comfort, for it tells you that life, like physics, is not about clinging to certainties, but about flowing with possibilities, listening to whispers, resting in openness. And as you sink deeper into this awareness, another question arises softly. If the quantum world reshapes how we see reality, if it invites us into philosophy and humility, then what future awaits as these machines grow stronger, as our understanding deepens, as possibility becomes practice, and that, the story of horizons yet to come, is where your journey flows next. You breathe slowly, deeply, letting the dreamlike reflections of philosophy fade into quiet starlight. And now you find yourself standing at the edge of time, gazing forward into what has not yet come, the horizon of quantum futures. A place where the story of qubits and gates and entanglement extends beyond laboratories, beyond algorithms, beyond even the poetry of philosophy, into the lives of people, into the fabric of society, into the destiny of humanity. And as you rest in calm awareness, you begin to imagine the horizon itself. A thin glowing line where night meets dawn, where possibility becomes reality, where quantum whispers already rising today stretch into the vastness of tomorrow. And you know that this horizon is not fixed. It is fluid. It shifts with choices, with care, with patience. And so you are invited not to see it as a single future, but as a superposition of many, each waiting to be chosen, each shimmering softly like stars at the edge of vision. Breathe gently, and imagine one future where quantum computers model molecules with such precision that medicines are designed like poems. Each folded protein a stanza, each chemical reaction a verse, and diseases that once lingered in shadows are dissolved by clarity, not by chance but by deep understanding. And then another future, where quantum optimization untangles the complexity of cities, guiding flows of traffic and energy with such harmony that waste is reduced, time is saved, resources conserved, and daily life feels smoother, more balanced, shaped by the quiet guidance of algorithms woven from probability. Pause here and imagine another horizon, where quantum communication stretches across the globe, photons carrying secrets in light, building networks not of vulnerable codes but of unbreakable trust, satellites shimmering above like messengers of intimacy, binding nations, people, hearts together with threads that cannot be broken without notice. And in this vision you see not only technology but trust reborn, secrecy protected by nature itself. Breathe again, slower now, and let your mind drift to yet another horizon, one where quantum intelligence entwines with classical, where artificial minds trained on data are deepened by quantum whispers, learning not only from patterns but from probabilities, from fog itself, offering insights richer than either alone. And though this future is uncertain, its possibility glows softly, a reminder that horizons are not predictions, but invitations, spaces of openness waiting to be explored. Drift further, and imagine horizons even larger, where quantum simulations model the Earth itself. Climate systems woven into equations too vast for classical thought, yet within reach of quantum computation, offering clarity in the time of great change, guidance to preserve oceans, forests, skies, to balance humanity with nature. And in this vision you feel a calm responsibility, a reminder that quantum futures are not only about power but about stewardship, not only about what can be done but about what must be done wisely. Pause and breathe and reflect. Each horizon is a possibility, not yet real, not yet fixed, shimmering like a qubit before observation. And the future of quantum is not only in machines, but in choices, in ethics, in humility, in how we wield the quill that can write upon the manuscript of atoms, in how we guide the lanterns that glow in the fog of probability. And as you drift deeper into this awareness, you realize that the truest horizon of quantum computing is not the machine at all. It is the human spirit that dreamed it, the capacity of the mind to listen to whispers, to faint for sight, to imagine realities beyond common sense, to reach into the uncertainty of the cosmos and find not fear but wonder, not despair but possibility. Breathe once more, softer now, and let the horizon stretch infinitely before you, filled with shimmering maybes, filled with futures yet to be chosen, filled with the gentle reminder that you, too, are part of this story, that you, too, are woven from quantum whispers, that your life, your choices, your breath, are superpositions collapsing into moments, each one shaping the path forward. And as you sink into rest, you carry with you the final comfort that the horizon of quantum futures is not only out there, in machines and labs and theories, but also within you, in your openness, in your wonder, in your willingness to live with mystery. And though the chapters of this story may close, the poem continues, whispering across time, carried by light, carried by possibility, carried by you.